Aging is a complex but natural process that affects every molecule, every cell, every organ, and ultimately your entire body functions. And although chronological aging is inevitable, unfortunately, unlocking the secrets to biological aging has perhaps been the ultimate scientific quest for many years. Most recently, scientific research is focused on the way our cells age and how aging impacts their function, reproduction, and ultimately the lifespan of our cells. This may help us to better understand the causes and ultimately the potential solutions for key age-related diseases such as heart disease and cancer. We've all known people who look old for their age. Clearly there are genetic factors involved there, lifestyle factors, nutritional factors that all affect how we age. But now much is known about these cellular processes that incorporate these various factors and lead to people aging slowly or more quickly. The first way we age is due to DNA damage. Our DNA is under continuous assault from ionizing radiation, from toxins in the environment, and even as a result of just the normal processes of metabolism. And up to 1 million DNA damaging assaults occur every single day. And these can result in genetic typos or mistakes in the DNA replication. Now, these mutations can accumulate over time, eventually causing cells to malfunction and even die prematurely. Our bodies, though, have repair mechanisms that take care of this DNA damage. However, defects in DNA repair seem to be directly related to the aging process. This critical balance between protecting the DNA from damage as well as repairing DNA is an ongoing area of active research. Another process that leads to aging as well as disease is the activation of genetic regulators, which are also known as transcription factors. These impact a multitude of metabolic processes in our bodies, including the dynamic balance between DNA damage and repair, also between energy production and decline, and control cell lifespan. Over time, the activity of these genetic regulators seems to decline and cumulative cell damage can occur. This cumulative damage contributes to age-related cellular deterioration and also contributes to many diseases of aging, including cancer, kidney failure, and even dementia. The third way that we age is related to cellular structures called mitochondria, which are the intracellular power plants that transform carbohydrates, fats, and proteins from the food that you eat into energy that your body can use. But free radicals are also generated in this process, which can lead to serious damage to your mitochondrial membranes as well as to DNA. This oxidative damage accumulates over time, leading to decreases in both the number of the mitochondria in our cells as well as their function, and can contribute to the development of many age-related diseases, including heart disease, arthritis, and Alzheimer's disease. As we age, our proteins and other structural molecules develop damaging crosslinks to one another through a process called glycation. Glucose molecules attach to proteins, forming what are called advanced glycation end products, also known as age proteins. The accumulation of these cross-linked damaged proteins are somewhat like plaque building up in your arteries, and they are tied to some of the most debilitating effects of aging. In fact, scientists are theorizing that these age proteins may play an important role in the development of atherosclerosis, as well as certain complications of diabetes and chronic kidney failure. Scientists are investing billions of dollars in research on aging. It's estimated that the National Institutes of Health spent over $2.4 billion alone in 2007. And much of this latest research on aging has focused on topics that we have talked about: preventing DNA damage and supporting DNA repair, positively influencing these genetic regulators of longevity pathways, enhancing mitochondrial biogenesis, and reducing the accumulation of these age proteins. Recent research has focused on the beneficial effects that certain plant polyphenols have shown in laboratory studies on these cellular mechanisms of aging. Polyphenols are natural phytonutrient compounds that are found in the fruits and vegetables that we eat, and they've been shown to have antioxidant and anti-inflammatory activities, and literally thousands of studies support their potential utility in human health. And recent research has focused in on one particular polyphenol, resveratrol. You may have heard about it. It's a particularly powerful polyphenol found in red wine and has effects on cellular aging processes. In fact, laboratory studies demonstrate that cells treated with resveratrol were more resilient to DNA damage and more effective at DNA repair. Additionally, laboratory studies also indicate that certain polyphenols promote cellular energy biogenesis and promote healthy mitochondrial function. In fact, in laboratory studies, resveratrol has been shown to exert multiple protective effects against metabolic syndrome through the promotion of this mitochondrial biogenesis. And a landmark study published in 2006 by Dr. David Sinclair at Harvard Medical School showed that resveratrol positively impacted the harmful effects of a high-fat diet on the heart and the liver and decreased the development of insulin resistance. Activating key transcription factors, also known as genetic regulators, is critical for cellular health, for repair, renewal, as well as for cellular longevity. Plant polyphenols have been shown to trigger these key genetic regulators of cellular energy metabolism, as well as longevity, which will positively impact these cellular aging processes. And recent studies show that certain plant polyphenols can limit the formation of advanced glycation end products, these age proteins, thus leading to their reduced accumulation and promoting cellular health and longevity. Specifically, polyphenols found in the American species of grape, Vitis rotundifolia, as well as other botanicals including elderberry, seem to have the ability to slow the formation of these damaged age proteins. So where are we today? Well, science has proven that many of the chronic diseases, as well as leading causes of death, can be prevented or at least controlled, and often through simple lifestyle changes. The National Institutes on Aging emphasizes that achieving and maintaining health and function in advanced years can be aided by a commitment to a lifestyle that promotes fitness, proper nutrition, maintaining a healthy weight, and avoidance of smoking and other behaviors that adversely affect your health. But the good news is that even if those healthy habits have been neglected, research shows that it's almost never too late to begin those good habits.